Hello everyone. Today our topic is going to be geometry and mensuration. So we'll start with geometry and mensuration. First we'll discuss what are the topics which are in geometry and mensuration. We start with lines, angles and polygons. Then after we'll see triangles, then quadrilaterals, then we'll go for circles, then we'll go for solid geometry. You also call it three-dimensional geometry, then coordinate geometry. Let me explain you the logical sequence of these chapters. First, lines, angles and polygons. We start geometry with a point. If you draw this point, if you drag it, it forms a line. For this line, you can only measure the length of this line. Let's take it as a line segment. At any vertex of this line segment, if you see, there is only one dimension you see. So you can only find out length of this line segment. Like you can imagine a piece of thread or else a pen or pencil with a negligible thickness. You can only find out a length of it. If you drag this line, you get a two-dimensional figure like this. Let's say it is a rectangle. It has four vertices. At any vertex, if you look at, you'll have length and breadth. Two dimensions you'll have. So for a rectangle, what do you find? You find out the perimeter of a rectangle and you find out this space. The white space is nothing but area. So for a rectangle or else for a two-dimensional figure, perimeter and area will be discussed. If you drag this rectangle furthermore, it looks like a cuboid. For a cuboid, you'll have at any vertex of a cuboid you look at, you can imagine a room so that you are presently sitting in. Any vertex of a room, if you look at any corner, you'll find three dimensions, that is length, breadth and height. If you imagine the wall of a room, it is a two-dimensional figure. Assume that for a wall of a room you have a board. So if you look at that board, it is only a two-dimensional figure. For a frame, for a board, the frame of the board is nothing but the perimeter of the board. The region where we write is nothing but the area of that board. If you imagine a room that you are sitting in, so any corner or any vertex of the room, any corner you look at, you'll find three dimensions for that particular room. So you have the extra dimension called height here. This height will make some space, okay, where we are sitting. This space is called volume. So here at any vertex you find three dimensions. So three-dimensional figures. For walls you find out surface area and that space is nothing but you call it volume. So when I am saying only length, I am talking about unidimensional figures or a single dimensional figures. When I am talking about perimeters and area, I am talking about a two-dimensional figure. So when I am talking about volumes and surface area, I am talking about three-dimensional figures. So first we will start with the unidimensional figures, that is lines. Lines, angles and polygons. So in this lines, angles and polygons also, first we take a line. If we intersect lines, you get angles. So we discuss intersection of lines with the angles. What are the different type of angles formed? If more than two or three lines are intersected, polygons are formed. So polygons with three sides are called triangles. So we discuss triangles in detail as a separate chapter. In triangles, we are going to look at what are the different type of triangles we have, how a triangle is formed. So those things based on the sides and angle, how we differentiate triangles. So how do we have different triangles based on sides and angles. Based on sides, you will have equilateral triangle, then after scalene triangle, then after isosceles triangle, then after based on lines, you will have an acute angle triangle, obtuse angle triangle, and their properties, their centers associated with. So all those things we'll discuss in a separate chapter called triangle. If a four lines are intersected, a polygon is formed, we call it as a quadrilateral, like a square, a rectangle, a rhombus, all those things, trapeziums, and their properties, their perimeter, how do we find out the areas, we discuss it in quadrilaterals. So that will be another chapter. Then again, a polygon with infinity many sides, you call it as a circle. So in circle also there are many terms which are associated with it, like radius, area of the circle, perimeter of the circle, circumference of the circle, tangent, chord, sector, segment. Those things we'll discuss it in circles. All these things will represent on a coordinate plane, on an xy plane. So for which you have, first we'll start with the location of points. Then after we'll find out slope of a line. Then after what happens when two lines intersect, where exactly they'll intersect, how much angle they make with x-axis, how do we locate it, how do we find out the image of those lines. All those things we'll discuss it in coordinate geometry. Then after that we go for three-dimensional figures such as cube, cuboid, sphere and all, that will be discussed in three-dimensional one. Now we'll start with a line. I said a line makes how many degrees of angle? A line makes 180 degrees of angle. If you intersect two lines, let's assume that the angle between two lines is theta. We know a line makes 180 degrees of angle, so the remaining angle will be 180 minus theta. Now this also make a line again, so it forms a linear pair. So this again becomes what? 180 minus theta, and this angle must be, these two angles, sum of these two angles must be what? 180 again, so therefore it is theta. Now this becomes, it forms a linear pair. Linear pair means it makes a straight line. So again, which is 180 minus theta. So from this, if two lines intersect, you can clearly see here the vertically opposite angles are equal. So we say when two lines are intersected, vertically opposite angles. Suppose a question is asked based on this. This one is 5x, this angle is 4x, angle is y plus 36. If I ask you what is angle y, y in terms of degrees, from this you can say 5x and 4x forms a linear pair, therefore, which means it forms a straight line. The angle is 180 degrees. 9x is equals to 180 degrees. X is equals to 20 degrees. When x is 20 degrees, 5x is 100. We know vertically opposite angles are equal, therefore 5x is equals to y plus 36, which is equals to 100. Therefore angle y is equals to 64 degrees. So here the property used is vertically opposite angles are equal and a straight line makes 180 degrees of angle. Both we have used. Now we'll learn more about the angles. If I take a straight line, I'm dividing this into, to represent the angle, I'm starting it with 0, 90 degrees, 180 degrees, 270 degrees, then 360 degrees. First of all, you call it 0 angle, you call it right angle, we call it as a straight angle. Sometimes they'll say angle is 180, sometimes they say straight angle, sometimes they say 90, sometimes they say right angle. Here it is a reflex angle, just you call it as a reflex angle. 360 is called complete angle. Any angle which is in between 0 to 90, we call it as an acute angle. Acute angle is an angle which is in between 0 to 90. Angle which is in between 90 to 180 is obtuse angle. An angle which is greater than 180 up to 360, We also call this angle as a reflex angle. 0 to 90 acute, 90 to 180 obtuse, 180 to 360 we call it as a reflex angle. In addition to this, suppose if two angles, this is a right angle, I am dividing this right angle by using a line. Let us say this angle is A, rest of the angle is B, and we know that A plus B is equals to 90 degrees here. See, even if I exactly draw 90 degrees, suppose if this is given in the exam, angle AOB. What is angle AOB? If I ask you, we don't know what is the angle AOB because the symbol is not given. Unless until the symbol is given, you can't take it as 90 degrees. Even though if it does not look 90 degrees, exactly perpendicular. If it does not look exactly perpendicular, suppose if this is given, but a symbol like this is given, so it means 90 degrees. So here A plus B, both sum of these two angles forms 90 degrees here. You call A comma B are complementary angles, where complement angle of A is actually B, or else you can say 90 minus A. Here angle B is equals to 90 minus A. So their sum is 90 degrees. If I take a straight line in the same manner, the angle formed by a straight line we take it as 180 intersected by a transversal or else a line. Now here angle A and angle B. Here angle A plus B is equals to 180 degrees. Whenever the sum of two angles is 180, we call these angles are A comma B are supplementary angles. If I ask you what is supplement of A, supplement of angle A, say it is 180 minus A or else B. If I ask you what is supplement of B, that is 180 minus B or else A. If I take a complete angle, this is complete angle which represents 360 intersected by a line. This angle is A, this angle is B. Now here in this case A plus B is equals to 360. A comma B are we call it reflexive angles. What is reflex of A? Reflex of angle A is angle B, or else we say it is 360 minus A. So we have seen complementary angles, supplementary angles and reflex angles. If sum is right angle or sum is 90 degrees, we say complementary, 180 degrees we say supplementary. If it is 360, we say reflex angle. Now what kind of questions can be asked by using it? What is an angle which is 5 times of its complement? So he is asking you what is an angle which is 5 times of its complement. Let the angle B is equals to A. I want an angle which is 5 times of its complement. Complement of A is 90 minus A. A is equals to 5 into 90, don't multiply it, minus 5A. If minus 5A goes this side, it becomes 6A. 6A is equals to 5 into 90. A is equals to 6 ones are 15s are. Therefore, the angle that we are looking for is 75 degrees. You can just verify it also. 75, the complementary angle of 75 is 15. Now look at 75 is how many times of 15? It's 5 times of 15. So I am asking you an angle which is 5 times of its complement. This is one way of doing. The other way of doing, an angle which is 5 times of its complement. Complement B what? B. We know complementary angles means A plus B is equals to 90 and A is 5B. Therefore, 6B is equals to 90, B is equals to 15. But I am looking for angle A. Angle A is equals to 5 times of B, which is 75. So, like this also you can do it by using two variables. If you don't want to use two variables, you can use one variable and do it. Similar way, what is the greater angle? In a pair of supplementary angles which differ by 36 degrees. I want a greater angle in a pair of supplementary angles which differ by 36. First of all, you should know what are supplementary angles. The moment I say supplementary angles, their sum is equals to 180. And I am also saying they differ, which means the difference between these angles is 36. Since I am asking you the greater angle, just cancel them. A is greater, B is lesser, because A minus B is equals to 36. 2A is equals to 216. The greater angle is 108. If I ask you what is the least angle in a pair of supplementary angles which differ by 36, angle A is the greater angle which is 108 and angle B is the smaller angle which is 72. So, same way I can give you the question based on reflex also. It will be the same. Now, take two lines, two parallel lines which are intersected by a transversal. So, I am taking two parallel lines which are intersected by a transversal. These arrow symbols represent that they are parallel lines. See how many angles are formed. There are 1, 2, 3, 4, 5, 6, 7, 8. So, there are 8 angles formed. I am naming them. Let it be 1, 2, 3, 4, 5, 6, 7, 8. First, look at angle 1 and 3. We know angle 1 and 3, vertically opposite angle, 2 and 4, vertically opposite angle, 5 and 7, vertically opposite angle, 6 and 8 are vertically opposite angles. So, these are vertically opposite angles. What we know about vertically opposite angles? Vertically opposite angles are always equal. Now, look at the angle 1 and angle 5, angle 2 and angle 6, angle 3, angle 7, angle 4 and angle 8. Look at angle 1 and 5. This you call it corresponding. In place of 1 you have 5 here, in place of 2 we have 6 here, in place of 3 we have 7, in place of 4 we have 8. So, we call it corresponding angles, and corresponding angles are also equal. These are corresponding angles. What do you know about corresponding angles? Corresponding angles are always equal. Now, look at angle 3, 5, angle 4, 6, 3 and 5, 4 and 6. You call them alternate interior angles. This alternate interior are also equal. It can be in the shape of Z, like this, inverted Z, extended bit, can be in any of these 4 shapes. So these are all alternate interior angles. Look at 1 and 7. Look at 2 and 8. These are exterior and these are alternate also. Therefore, we call it alternate exterior angles. So alternate exterior angles are also equal. So all these angles are equal. Now we left with, look at angle 3 and angle 6. Angle 3 and 6, angle 4 and 5. They are not equal, but you call them one side interior angle. The sum of angle 4 and angle 5 is equals to 180 degrees. We call them one side interior angles. They are not equal, but their sum is equals to 180, which means they are a kind of supplementary angles. If you look at here carefully, we are just taking totally 8 angles. But in fact, if you look at closely, angle 1, vertically opposite angle, angle 1, angle 1 to the corresponding angle, angle 1. Again here angle 1. Take the rest of the angles. If I take this as angle 2, vertically opposite angle 2, corresponding angle 2, alternate interior angle is also 2 to this. So we are seeing 8 different angles, but there are only 2 different angles we found. We have seen 8 angles, but out of which there are only 2 different angles, and the sum of these angles, angle 1 plus angle 2, is equals to 180 because they form a linear pair. They form a straight line. Therefore, angle 1 plus angle 2 is equals to 180. There are different names so that you can identify those angles. Okay, in order to identify, I am giving different names for it. I am just taking 3 parallel lines. Take L, M, N or 3 parallel lines. If this angle is 89 degrees, this angle is 29 degrees, then what is angle X? So angle X I am looking at. Now see here, 89 degrees, let this angle be Y. L, M, N are parallel. L is parallel to M, M is parallel to N. If you look at 89 degrees, comma 29 plus Y are alternate interior. When I say alternate interior, you can just identify them. So alternate interior angles are equal, therefore Y plus 29 degrees is equals to 89. Therefore Y is equals to 60 degrees. Now if you look at X and Y, if you expand it a bit, you can just understand that they are one side interior angles. They are not equal, but X plus Y is equals to 180 as we mentioned. X plus Y is equals to 180 means X is equals to 180 minus Y, that is 180 minus 60 degrees, which is equals to 120 degrees. So to identify the angles, you should know what are alternate interior, what are one side interior angles, what are alternate exterior angles, what are corresponding angles and all. If I take 2 lines, let us say point A, O, B. If I give you this as angle X, this is angle Y. What is angle AOB, the central angle AOB? See here, angle X, vertically opposite angle, X degrees, vertically opposite angle, Y degrees. Draw an imaginary line here. We can say these two are corresponding. Therefore, angle X, this is angle X. If it is Y, These two are corresponding, therefore it is y. Now what is angle AOB? Is x plus y degrees. If you look at the reflex of AOB, which is equals to 360 minus AOB, which is nothing but x plus y. So this is how we find. See here, if I take a triangle, two parallel lines, a triangle. First try to understand what is the sum of interior angles of a triangle. I am taking a parallel line which is parallel to its base. I am taking a line which is parallel to its base. Angle A, angle B, angle C. Let this triangle be ABC. If you extend the base of this triangle, it looks like exactly they are parallel lines, isn't it? Now look at this angle and this angle B. It's in the reverse Z shape, and we know that they are alternate interior angles. Therefore, this angle is B. A and here, it is in the shape of Z. It is alternate interior angles. This angle is A. Therefore, what is the sum of interior angles? Sum is equals to angle A plus angle B plus angle C. So therefore, angles in a triangle is equals to 180 degrees because it forms a straight line. See here, it is forming a straight line. Therefore, angle A plus B plus C is equals to 180 degrees here. If you look at any external angle of a triangle, if this is angle A, this is B. The external angle of a triangle, the external angle of a triangle is, this is C, right? Let's say the external angle is x. We know A plus B plus C is equals to 180. Just now we found. Now we also say x plus C is also what? 180. So what should come in place of x? A plus B. That is the reason we say the external angle to a triangle, to any particular angle you take it. So the external angle of a triangle is sum of two opposite interior angle of the triangle. So if I am taking external angle to C, then it is the external angle corresponding to C is sum of two interior, other two interior angles, that is B plus A or A plus B. So angle x is equals to A plus B. If you take this external angle, it will become what? A plus C. Like that it becomes. So based on the property that we have discussed, we can solve many sums. Suppose in this diagram, if I ask you, let's say this angle is A, this angle is B, angle is C, angle D and angle E. In this pentagon, in this star, I am asking you what is angle A plus angle B plus angle C plus angle D plus angle E. What is the sum of these 5 angles? Now if you closely observe this, look at this particular angle. See the region in the red color. This red color region is a triangle, and this particular angle is the exterior angle of this particular triangle. We know that exterior angle is what? Sum of two interior angles. Now what are the sum of two interior angles here? C plus E. Therefore this angle becomes C and E. In the same manner, look at this angle, this pink color one. Now look at this pink color triangle. Now this becomes the external angle for this pink color triangle, and what is this angle? Angle B plus angle D. Therefore it forms a triangle. You can see it clearly here. What is the sum of angles in a triangle? A plus this 2 is b plus d, the other 2 is c plus e. Sum of 3 angles in a triangle is 180. So, now by looking at it, you can say this 5 angles sum is 180. So, in the next class we will discuss some more properties of polygons. Thank you.